This is the Week in Sustainability from Workiva Carbon, formerly Sustain Life. It's where our team of experts and practitioners share weekly insights and commentary to keep you up to date about all things sustainability.
Hi, and welcome back to another week in sustainability. I'm Hannah Asofsky, Sustainability Data Analyst here at Workiva Carbon. And today we are going to be highlighting a new publication that deepens our understanding of Earth's climate history. So just last Friday, researchers published an updated timeline of Earth's surface temperatures throughout the entire Phanerozoic eon. A key result of this publication shows that the Phanerozoic eon was much hotter than previously calculated. Now, this study gives us so much more context as to exactly how drastic our current warming really is. So researchers kicked off this project almost 10 years ago when a team at the Smithsonian Museum of Natural History, they realized that they just didn't have a full timeline of Earth temperatures throughout the Phanerozoic eon. It just didn't exist. There were some reconstructions that existed over shorter periods of time, but this publication it really matters. It's the first publication to fully reconstruct the entire Phanerozoic. And I keep saying Phanerozoic, so let's talk about how much history this study seriously covers. Wrapping our heads around geologic timescales is hard, but I'll do my best. So the Phanerozoic eon marks the end of the Proterozoic eon. And the distinction between those two eons is the Cambrian explosion, which you likely last heard of in probably an early science class. The Cambrian explosion was about 500 million years ago. And it was when life on Earth it diversified from sort of multicellular and single cellular organisms that were semi-complex, that they all kind of lived in colonies. That bubble burst open and we got multicellular organisms and complex species, some of which are still around today. This is where we get calcium carbonate shells. So clams and mollusks and trilobites came onto the scene. Also some early skeletal fish come a little bit later. Thinking about a map, continents as we know it don't exist yet. We are still early in Pangaea's breakup. Uh, Between the Cambrian explosion and now, we get fish, we get plants that have seeds rather than spores. Enough time passes that organisms come out of the water. We get the evolution and then mass extinction of dinosaurs. It's too much drama to catch up on, really. And then we have humans show up on the scene. So earliest known Homo habilis shows up around 2 million years ago. And then the modern human, as we know, Homo sapiens, show up in Africa around 200,000 years ago. All of human history unfolds and brings us here. And this timeline, published in Science, is now the most rigorous reconstruction of Earth's past temperatures that we've ever created. The team used a technique called data assimilation, which mathematically aligns climate modeling and real world evidence. This is how our weather forecasts are prepared as well. It's the same statistical technique. And using over 150,000 globally distributed fossil evidence records and existing climate reconstruction models, the team produced the most statistically robust timeline to date. There are two components of their results that I want to focus on specifically. One is the biggest result, which is that the historic temperature range that we had previously calculated was incorrect. It's actually much larger than we had previously thought. So throughout the last 500 million years, global mean surface temperature has moved between 11 and 36 degrees Celsius. In Fahrenheit, that's 51 and 96 degrees. So remember, these are global averages. These are describing the entire planet at any given point in time. A 96-degree day might be a reasonable summer day, but a 96-degree Earth means no polar ice caps, no glaciers. We don't have a firm grasp on what the ecology of a planet that hot could be like. Humans evolved in the lower range of that entire history. So what we are experiencing right now is around 59 degrees Fahrenheit. We evolved closer to 51 degrees Fahrenheit. We are currently experiencing the hottest temperatures that humans have ever seen on this planet, and we've exited the range that we evolved within. And then the second point that stuck out to me was a little bit of a confidence boost, kind of agreeing with all prior climate science. Their results reinforce that atmospheric carbon is this key dial on global temperature. Climate science has told us the higher the carbon dioxide levels, the higher the temperatures. And we should feel kind of empowered by this, knowing that carbon dioxide levels will breed lower temperatures has been true for longer than we've been here, longer than we've had words for that relationship. So how should these results influence or shape our perspective today? For one, let's look at the speed of today's warming, look for patterns similar in the record and draw lessons from that. The reflection here is really straightforward. The last time that we saw temperatures increase this quickly, volcanic eruptions were to blame. We saw a 10 degrees Celsius increase over 50,000 years, which is considerably slower than what we've witnessed since the industrial age of human history. That was 250 million years ago, and it's today known as the Permian Triassic extinction. That increase of 10 degrees Celsius over 50,000 years wiped out 90% of species on Earth. If species weren't able to evolve within 50,000 years, that doesn't bode well for our future. Plants and animals, us being animals, can adapt within our own lifetime. And then something else that we see in the research is the temperatures were trending downward before our industrial revolution. Again, this supports climate science that fossil fuel combustion is to blame for temperature increases. Natural geochemical cycles that could emit CO2, that do emit CO2, are not responsible for the warming that we see in our lifetime. They don't happen this quickly. They don't impact on that scale. So sure, fossil fuel combustion is to blame for climate change, but we also have the agency to reverse it. At the end of the day, this is a new addition to our already mountain of evidence that temperatures are rising due to human activity. And positive spin there means we know what to do to undo that warming. Corporate reliance on fossil fuels is driving temperatures up, but it also means that our companies, our businesses are in the key position to lead charge in abandoning our reliance on them. This is just the quickest deep dive into our planet's historic temperature record. And if that wasn't enough detail, then I highly encourage everyone to check out the full publication, last week's issue of Science, and we will see you next week.
Workiva Carbon provides organizations with an easy-to-use solution to manage the full life cycle of measuring, managing, and reporting carbon emissions. Now integrated into the same platform used to manage the world's most trusted financial and non-financial reporting. Don't forget to like and subscribe to this show on our YouTube channel or your favorite podcast platform. See you next week.